All right, here we are in Blender. I wanted to give you guys a quick just like tutorial or lesson or something here on the track 2 constraints in regards to simulations in geometry nodes. Let me show you my setup here real quick. We have a point, the object here. We have a target, the target here. And so most people do the general location subtract the position. So the location of this subtract the position. And they'll run that into their simulation. So I have a stored named attribute outside of the simulation. I have a set position node here, scale, and then it's being scaled by the named attribute of that was stored here of track. So let me just go into this here and show you a few things here. So the first is just going to be a visualization of what it looks like using just the location output from your target. This is going to give you a vector that is going to follow always, no matter where it's at. So location in this case is going to be, well, the vector that it's giving here is always going to be from 0 to that location, right? So let's see what that looks like here. Right? It's going to follow it out. If I was to change this location at all, it's going to follow it still exactly parallel to this line here, right? So, and that's the case no matter where this is, right? There. Let's go back, put it down here somewhere. Right? It's always going to follow that same orientation here. So let's go back, put this back at 2, just for... All right, so then what does the other look like? Taking the location of the target and subtracting the position, right? So if right now the location of the target is 4 on the Y, 2 on the X, and 0 on the Z, and this location is 0 on the X, positive 2 on the Y, and 0 on the Z, then subtracting this should result in a vector of 4, right? Which means that instead of this following up, right, instead of the constant 2 up that it's following, that this is as well, it's instead shaved that off and now going to go to it, right? So it's not following the same vector from 0 anymore. It's going from where it is to the target, right? All right, so hopefully that's clear. Now, let's look at what it looks like if you were to go and take this named attribute and put it inside of the zone so that it's updating on every frame. So again, let's go here. You have this, and it's going to infinitely go up, similar to what you had before when it was outside of the zone, because the vector didn't change, right? You say, okay, well, let's see what it looks like if we were to change the vector in real time, move the target while it's going. Well, remember, so this vector is currently just saying go positive 4 in the X, positive 2 in the Y, and don't move in the Z every frame forever, right? But if we start adding or subtracting from it by moving this and it's being stored every frame, you'll see what happens here, right? We have this kind of follow motion going on here. And that's because it's changing that vector every frame. But again, it's not tracking to it necessarily. It's saying that original vector is being changed by a new vector that's determined by the location of the target, right? Now let's see what this looks like if we go back and change this instead to the location minus the position of this. Still following it, but you'll notice that it has this effect where it will reach it and stop. It's always going to attempt to reach that target, but it's not going to go past it. The other one, right, is just updating it and it will go past it. But if you go in the negative, it'll go past it. You're just adding and subtracting based on every frame. Here, you're doing the same, but it's always trying to reach it. Now again, let's look at this visualization I have here and as to why this is. And you may have already noticed it, but watch what happens when I press play here. You'll notice this speed ramp effect happening, right? And what's going on is because you're subtracting the position of this target from this position every single frame, right? So you will get this infinitely diminishing number, right? And so that's where you end up getting this speed ramp, and that's why a lot of people will normalize this and then scale it inside of there. We don't have to explain that, but let's do one more thing here and explain, pull this back out and explain what delta time looks like, right? So you'll notice that I have my named attribute scaled by delta time. And what does that mean? It means, let's put this back so that we can visualize it clearly. So if we were to take the target location minus the position and press play, when should we expect this to reach there? Currently, the frame rate of this project is set to 24. And if you pause it, frame 25, it gets, the point is exactly where the target is. And that's because of delta time, right? So that's just, this stuff gets a little bit complicated when you're first beginning, because it's kind of like, okay, well, my speed is determined by some sort of scale of the vector. And that's true, that can be, but it's also determined and can be more easily balanced through your delta time. So again, this gets there at exactly 25 frames. And that's because this starts at frame 1, right? So if it's 24 frames per second, it takes 1 second to get there. That happens on frame 25 because frame 1 is where it started, all right? And we can prove this by going to 60 frames per second, right? And play this now. When do we expect this point to reach the target? Frame 61, right? And that's because it's being scaled by delta time. Anyways, I hope that this helps understand a little bit the different track 2 constraints that you can do inside of simulations and why you would want to use one over the other, or what's really going on kind of under the hood there. I also have this vector viewer, which is how this is being seen. Things like the real-time coordinates of where that's at. All sorts of things. I am going to put this up on my Gumroad for free. So if you're interested, feel free to follow the link and pick that up and use it for however you want. It's nice for just certain visualizations. You can have some options here. You can set out just all sorts of different options. But anyways, yeah, if you're interested, pick it up for free on my Gumroad. And if you have questions, ask in the comments below or ask me on X, and I'll do my best to answer them for you. I hope this wasn't super confusing and made a little bit of sense and helps you get a clearer picture as to what's going on and why you would use maybe the location of your target as opposed to the traditional location minus the position. Anyways, again, if you have any questions, let me know. Please sub to my channel. I lost my old one, and so I'm trying to build this one up. But either which way, I'm going to keep posting these because they're beneficial to everyone trying to learn this program. All right, I'll catch you in the next one.